Good morning, third graders. I want to take some time to go over our DMA. Thank you so much for those of you who are coming and checking your DMA. It's helping a lot with those skills that you're going to need for fourth grade. So keep coming back and keep reviewing. Nice job. Give yourself a thumbs up if you're one of those people that comes every day and does what they're supposed to. I appreciate it greatly. So let's take a look at our first problem. You'll notice that right here we have two multiplication symbols. Wow, two multiplication symbols is tricky because we have to take groups and multiply it by groups again. So I'm going to model for you what this looks like. So when I have 8 groups of 2, I take that first idea, I take this first. And I say 8 groups of 2. So when I think about 8 groups of 2, I think about an array, okay? So if I do think about an array, I go 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 rows with 2 in each row. So this is 8 groups of 2, 8 times 2. But now, instead of just having 8 times 2, now we're going to do this 8 times 2 4 times. So we're going to have 4 groups of 8 times 2. You're like, wow, Miss Emil, we're getting into some tricky stuff. Yes, we are. Okay, so let's take a look at 8 times 2 a second time. So this is 8 times 2 also. So now I have 8 times 2 again. That's a second time. We said we were going to do it 4 more times. 4 groups of 8 times 2. So here's 8 times 2 again. Oops, that doesn't look very nice. 8 times 2 again. And finally, we're going to do it a fourth time, and we're going to have 8 times 2 a fourth time. Now, wow, we're having to count a lot. Now, instead of us having to count all of these 8 times 2 groups, which would be 16, right? Because this would be 16. And this group would, oops, sorry guys. And this group would be 16. And this group would be 16. And this group would also be 16. Now, I can take those 4 groups of 16 and add them together. So I say 10, 20, 30, 40. And then 6 plus 6 is 12, plus another 6 is 18, plus another 6 is 24. Now, when I add those all together, when I add up all 4 groups of 16 together, I get 64. Okay? So yeah, we're getting into, instead of just one multiplication symbol, now we have 2 multiplication symbols. So like I said, we have groups of groups together. So 8 times 2, not just once, not just this one time to make 16, but we're going to do it 4 times. Okay? Now, there's another way that you can also think about this. And I'm just going to erase this. And remember, it doesn't matter what order It doesn't matter what order we multiply in because it's still going to be the same product. Remember, we can switch factors around and it'll still be the same product. So what if I were to do 4 times 2 or 2 groups of 4? So I'm going to flip this over and I'm going to demonstrate 2 times 4, but this time I'm going to do that 8 times. So 2 times 4 is 8. So two groups of four, two rows with 4 in each row. So that's once, one time. Two times. Three times. Four times. 5 times. 6 times. 6 times. 7 times. 2 times 4. 7 times. 2 times 4. 8 times. Now I'm going to zoom out just so you can see. Look at how much I had to draw in order to show this idea of 2 times 4, 8 times. So each one of these two groups of 4 is shown, oops, it's not 2 times 4, two groups of 4, 8 times. So this would be 8 plus 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 8. So I have 8 groups of 8, right? Well, that's what we're doing here. We're multiplying 8 groups of 8, which is your 2 times 4. So what is 8 times 8? If you know your 8s really well, you know that 8 times 8 is 64. So whether you look at it with different factors, it should end up being the same product. Okay? So, again, 8 groups of 8 is going to be 64, or if I were to take 8 times 2, 8 times 2 is 16, and multiply that by 4, 4 groups of 16 would be 16 plus 16 plus 16 plus 16. And we said that would be 40, 10, 20, 30, 40. 6 plus 6 is 12, plus 6 is 18, plus 6 is 24. Again, 64. So, doesn't matter what order you multiply the factors in, you still are going to get 64. So I wanted to model that for you so that you can see what that looks like when you are taking that apart as groups of groups. Okay? So let's take a look at our next problem. Our next problem is asking us to use our division to help us finish the related multiplication fact. So we're missing a factor here. We're missing a factor. And the reason that we're missing the factor is we are going to use our division to help us with our factor. Now, remember, multiplication is related to division, okay? So this 9 right here is actually the quotient to this multiplication fact. This 12 in our dividend for our division is actually, if you remember, the quotient to our multiplication fact here. So we're looking for what's missing right here as our quotient. So product, we get that from the dividend here. Product, we get that from the dividend here. And now we can find our missing factor. So if I take 12 objects and I put them into 2 equal groups, I would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, how many is in this group? 6. How many is in this group? 6. So when I take 12 objects and I put it into 2 groups, I get 6 in each group. Well, that's what I'm missing here. I'm missing the factor 6. So I have 2 groups, 1, 2. I have 6 objects in each group here, And if I put those two groups together, I get 12. So again, multiplication is the opposite of division. So instead of me putting all the groups together, now I'm taking all the objects and putting them into groups and separating them, okay? All right, let's take a look at 9 divided by 3. So if I have 3 groups, and I put 3 in each group, how many's in each group? 3 objects in each group. So I partitioned into 3 equal groups. There's 3 in each group. I get 9 as my product, but I'm missing my factor here, which is this quotient. So the quotient is one of these 2 factors, okay? My quotient is one of those 2 factors. Let me move this out of the way. Hopefully that's not showing. Let's take a look at our next equation. We have 2 fractions that we're comparing. Remember, you're going to label your unit fractions. This is in 6 equal parts, 1, 2, 3, 4, 5, 6. Each one of my pieces is a unit fraction. Unit means one of the pieces. This is in 2 pieces. This is one of 2 pieces. And this is one of the 2 pieces. So this is one of the 6th, and this is one of the halves. Now we know we have the same numerator. How do we know that we have the same numerator? We can see that this is one piece, and this is one of the 2 pieces. Now, when you compare their size, remember you're looking at this 6th is going to be less than this half. And why is that? Because when you break something up, when you took this whole circle and you broke it up into 3 equal pieces and then you cut those into 2 more, you kept making those pieces smaller and smaller. Okay, so we could say 1/6 is, so let's take a look. I'm going to use my fraction strips. You see the fraction strips. Here's my half, and here's my 1/6. I can see that 1/6 is smaller or less than 1/2. So one of my half pieces is greater than one of my 6 pieces. But remember, we read like a book. So one of my 6 pieces is less than one of my half pieces. So really, I'm looking at it more like this, right? I'm looking at the 6th first and then the half and reading it like a book from left to right. Okay, let's take a look at the last one. And we're going to look at true or false. The fractions half and 4/8 are equal to each other. Well, this is a square. This is one of the half pieces. And this is shaded, and it is also one of the half pieces. Now, you will also notice that when we use the same whole, which is my square, and they broke it up into 8 equal pieces, that each one of those is going to be 1/8 of my whole, 1/8. Now, let's take a look at the shaded section right here. This is 1/2, and this shaded section is 4/8. Now, if you compare shaded sections of each one of these squares, what do you notice? I'm hoping that you notice that this amount of this square is shaded the same amount as this square. So when we say equal to each other, equivalent, we're talking about the same amount but using a different fraction. So equivalent fractions are fractions that are equal to each other in an amount, but they may be partitioned into different sized pieces. So we can say that 1/2 is equal to 4/8. And yes, this is a true statement. And I can also model this by using my fraction strips. Oops, I'm using fraction strips. So I can take this 1/2 and I can take my my 8ths, and those are going to be my turquoise pieces, right? And I can see that when I line up these 4/8 with my 1/2, I see that 4 of my 8th pieces are the same as 1 of my 1/2 pieces. Does everybody see that? So I'm going to try this one more time, because the last time I asked somebody, or I asked the group to give me another equivalent fraction to 1/2, I didn't get very many equivalent fractions. So what I want you to do is I want you to take out your fraction strips, and I want you to leave your 1/2 bar or your 1/2 strip, and I want you to start lining up different fractions with the 1/2 and see which other fractions can you line up with the 1/2 that is going to equal 1/2. So I'm going to just demonstrate for you real quick. I'm going to take my thirds, and I'm going to see if I can make thirds equal to 1/2. So I'm going to take a third, and I'm going to take a third, and I line it up, and I'm like, oh, no, that is not equivalent. Why? Because I cannot make 1/2 from thirds. 2/3 is too much. And if I would have to take and cut that in half right there in order for me to do that. So that's what I want you to do for your discussion today. I want you to find one more fraction using your fraction strips that's going to line up and equal 1/2 with the 1/2 strip. So use these fraction strips, line them up against the 1/2, and see if you can make another fraction that is equal to 1/2. That's besides 4/8, not 4/8, because this already says 4/8, and we know that 4/8 is equal to 1/2. I want you to find another one using your fraction strips, okay? A different one. And again, you can't use 2/3 because it doesn't line up, right? This one does not equal 1/2. But 4/8 does equal 1/2. So let's see what you come up with. Play with your fraction strips a little bit. And I can't wait to see what you come up with. Have a great day.